Welcome to my channel. My name is Opubo. As the norm, if you are new to this channel, I say to you, welcome. And for one who is returning, I bid you welcome back. Good to have you return. You are all well appreciated. As the norm, in this channel, I present various ideas and designs of technologies, mostly from the Technology IP Bank of Enhanced Knowledge LLC, often integrated from several other technologies already in the IP Bank and made ready for adoption by the Adoption Brokerage Division. This presentation focuses on GGS ethanol process technology, one of the conservation economy supporting technologies that we have developed. And it focuses on large-scale production of ethanol for the use of fuel without impacting food resources or food, while enabling a conservation economy from the technological standpoint. And the approaches a community or region or even a nation could adopt to implement this technology to ensure the sustaining of a conservation economy. Ethanol, though, has been recommended as an additive to gasoline to cut back the quantity of gasoline used in automobile driving, as well as provide a market for the bioethanol producers to hold on as the world transitions to green energy, it was hoped. The measure was taken in view of the acceptance that though gasoline obtained from crude oil had been the mainstay of the energy industry, utilization of fossil fuel has been argued by some humans as damaging to life itself and should be discontinued, and the world transition to green energy, also called zero carbon energy resource, meaning the quantity of carbon released into the atmosphere balances the quantity removed by plant respiration or human efforts of negative emission towards gasoline equivalent, say, butanol production. Digressing for a moment, however, before delving into the issues with ethanol production and the capacity of this technology to overcome the issues, I implore you to please click the subscribe button now if you have not as yet subscribed to the channel. Go ahead and subscribe by simply clicking on the subscribe button below. The subscription would cause the system to keep you informed by notification of the next presentation the moment one is published, and also, of course, help me to more consistently continue to elicit the peace dividend of conservation economy. Now back to the presentation. Although recommended as additive to gasoline to cut back on the use of gasoline by motorists, has itself suffered some issues as a result of which the additive directive has not borne significant impact. First, the prices of the purchase of cash crop used, mostly corn, went up significantly as the demand went up. The supply remained constant. So the break-even analysis on which most cash crop-based ethanol producers entered the industry became invalid. As a result, several of the biofuel producers shuttered their doors as economics turned against them. Of course, the increases in the prices also impacted animal husbandry businesses, which took whatever necessary measures deemed advantageous to mount a sort of siege attack on the cash crop availability market, forcing an apparent shortage of the crops for even those bioethanol producers willing to pay the higher prices. Needless to state, the prices of food as a whole also went up as well, to the disadvantage of consumers, who then found the situation harder and harder to buy food for consumption. Attempts to use algae did not come up with very good outcome either, as the practice had not taken into account the use of phosphorus and large swaths of arable land for the raceway channel needed to cultivate the algae. In consistency with the thrust of conservation economy, the goal then became the development of a technology that enabled utilization of matter deemed waste within the context of the prevailing economics to produce the ethanol and help alleviate the underlying issues on which the ethanol additive directive rested. The process of developing ethanol by chemical sequestration of greenhouse gases, as per the video presentation GGS methanol process technology, link is provided below in the pinned up, then was motivation to develop the chemical production of ethanol, but a method that continued to utilize the greenhouse gases. The outcome of the effort is the technology of this presentation, GGS ethanol process technology, which in fact significantly the GGS uses the GGS methanol as key resource and as such completely circumvents the issues with food shortages and cash crop price increase, or even the concern of the requirement for large arable lands for algal cultivation, and of course the issue of the process engineering of a process design for biofuel. The GGS ethanol process technology obviously is an efficacious design, and being a design in the technology IP bank is available and is as shown in the schematics of the process. Conceptually, the technology is fed methanol and methane through a chemical reactor, which ignites reactions of the two components together to form ethanol. As a chemical reaction, the occurrence of ethanol is much faster than the biological process. By design, the process consists of a programmable chemical reactor, methane storage tank, methanol storage tank, liquid vaporizer, cooler condenser, fractionating distillation system, ethanol storage tank. Looking at the schematics, the design can be grouped roughly into 3 columns of equipment. The leftmost column has 3 equipment, with one at the lower level corner being the liquid vaporizer. Above it is the thermosiphon reboiler, and above that is the cooler condenser. In the middle column, there is at the top the distillation column with the boiler right below it, and below that then the programmable chemical reactor. The rightmost column has the methanol and ethanol storage tanks at the top and the 2 gas separator unit operations below that. The careful observer will note, if haven't watched the GGS methanol process technology video, that the process looks very similar, and that is because it is. The changes are the following. The mixer in the previous one had been changed to vaporizer, and the distillation column of methanol and water has changed to methanol and ethanol in this case. And the gas handling has changed. While in the methanol, the effluent gas was oxygen, here it is hydrogen and requires special handling, though not explicitly accounted for in the processing as not to distract. During the operation, methane gas and methanol are pumped into the vaporizer, with the methanol aspirated into the vaporizer and therefore undergoing fast vaporization from the heating of the chamber. The mixture of methanol and methane then flows into the chemical reactor, where a reaction is ignited between them that effects a carbon-to-carbon bonding, leading to the formation of ethanol in large quantities. The reactor effluent then flows into the cooler condenser, where the unreacted methane and any ethane formed are separated out, while the methanol and unreacted methanol are condensed into liquid and flows into the distillation boiler, where the liquid mixture is again vaporized and flows into the distillation column and gets separated into methanol and ethanol streams. The ethanol stream flows into the storage tank for ethanol, while the methanol stream gets recycled back to its storage tank for use in the process. The gas from the cooler condenser, on the other hand, flows into a gas separation unit operations and is separated into methane and ethane, with the methane recycled into the process for use, while the ethane is pumped into a storage tank designated for holding the ethane. The process trace given so far, there can be uniform acceptance at this time that there is, in fact, a conservation economy technology that produces ethanol source for use in every other conservation economic technology that requires energy. That the raw material is the product of the greenhouse gas chemical sequestration, and the one of the two gases, both of which can be obtained by negative emission capture, also effectively promises reduction of the volume of gasoline used while reusing the carbon already emitted into the atmosphere. Further, because the materials of construction of the technology has been mainly steel, the technology is well suited for the utilization of discarded metal parts in every region, allowing for the elimination of matter that would otherwise be branded as waste. So, under the requirements of conservation economy, this technology contributes to the utilization of whatever matter that is applicable within its context of use. Then, if interested in licensing this technology, please send an email to me. The email address is put in the pinned link below, as are other useful information. Regarding licensing consideration, though, there is some notes that should be of interest. The technology implementation or adoption clearly requires the co-adoption of the GGS methanol process technology, given the requirement of the use of the methanol. Hence, the licensing of this technology may in some cases also require the simultaneous licensing of the methanol production technology. That said, I wrap up the presentation by saying to you, thank you for being here, and I appreciate your coming to listen and to view the video, and hope and expect that you will consider coming back for the rest of the future technology presentations. The fact is, even if you do not adopt the technologies, some might just change your perspective of society and life. Until the next presentation, I wish you be well.